Okay. So for scalar vectors, today we're going to determine the sum, the scalar product, and the vector product of coplanar vector. Then we have resolve a vector of two perpendicular components. Okay. For scalar vectors, there are two. Actually, in physics, we have two kinds of quantities: scalar and vectors. Scalar is a quantities that are fully described by magnitude. It only has a number. And vectors is a quantity that has magnitude, numbers, and direction. Okay, so there's a difference between scalar vectors. Any example of a uh, scalar quantity, physical quantity? Google. Example of a scalar quantity.
Example of scalar quantity is uh, speed.
What is it?
Speed.
Speed. Okay, speed is scalar. Okay, and any more example of scalar quantity? Narin.
Velocity, acceleration,
Scalar.
scalar. So velocity
Scalar.
can, right?
No, it's under vector.
Oh. Mm.
Example of scalar. Scalar is a quantity does not have any direction.
So, length.
Length has length. Length is a scalar. Okay, it's a scalar. Displacement is a vector. Okay. Example of vector. Wei Yan. Wei Yan, are you there?
Oh, me, teacher.
Yes. How to call you?
Lin
Wei
Wei.
Yan?
Okay. Teacher, what you ask? Example of scalar,
Vector. Vector. Quantity.
vector, velocity,
Velocity. Any more?
displacement,
Displacement. Any more?
acceleration.
Acceleration.
That's all I can think about.
Okay. So that is a example of vector quantities. Okay. So in maths, vectors are geometric way to represent quantities that have direction. Okay, as magnitude. Okay, when vectors are written, they are represented by single letter. Okay, such as this is how to okay. So this is how you write A with a top at the top of here. Okay, with the yes an arrow on the top, or B with an arrow on the top, or C with the arrow on top. Okay, like that. Okay, so this is how you write a vector. Okay. Okay, so vector can be equal if both lines are parallel and the direction are same. You can see that in this diagram, lower right diagram. If A equals to B, both lines are parallel and direction are same, it is equal. B labels are same for both lines, and magnitude of A equals to magnitude of B, and direction of A equals to direction of B. So there are four things that you have to consider to say that it is equal or not. Okay. So you can see that in the diagram, A and B are equal, and on the right side, A and B are not equal, although they have the same magnitude, but they have a different direction. Okay. Now, sum of vector is when we going um, to add up two vectors. Okay, we have vector A and vector B, and we can also find out what is the resultant vector. Resultant vector is when you add up two vector, and then we want to find where is the net or the resultant vector after we combine two of them. There are two ways actually. One is by using parallelogram of vector, where you have put R1 on bottom and R2 on the top, and then this is using parallelogram. This, can you see the you can see this line and this line are parallel. This line and this line on top, bottom here and bottom here are parallel, and this line to the side and this line are parallel. So if you have it's easier if you have a graph paper. When you have R1 and R2, make sure this line and this line are parallel. You make a long line, and then this line and this line you make a long line. Okay, and then you can see where is the intersection between the two lines. It is the resultant of the R1 and R2, R1 plus R2. Or you can also, R1, you can put over here, and R2 you put as a B, then you can see that it is the end of this is we call as tail, and this is head of the arrow. The tail of the resultant is at the end of the A, or tail of the A, and the head of the resultant is the head of the B. Okay, so this is you can see that this is a simulation of the vector. So this is vector A. Okay, I can move up. This is vector A. Okay, let's say this is a force. It's easier to imagine as is a force. So force of A over here, somebody is pulled in this way, going up. And this is one more force, B. Somebody is pulling in this way. So you can see that they say this two is a string or rope. Somebody is pulling from end of the A over here, and somebody is pulling on the end of B over here. So let's say over here at the end of A and B is something like a table or something like a chair. Okay, so A will be pushing this way, pulling this way. B will be pulling this way. What you think the table will be moved to, right? Where is the direction of the table after two person over here is pulling? So you can see the sum of the resultant, the sum of the vector is going to this side. Okay, you can see diagonally, you call it diagonally. So the chair or the table will be going into this side because one person is pulling here, one person is pulling here. Okay, so what happens if we change the magnitude? Somebody is pulling very weak, like that. Somebody is pulling very strong. A pulling very weak, B is pulling very strong. So you can see that the direction of the chair or the direction of the table when it's moved is different. Okay. If I have same, okay, A and B have the same, we call as same, how to make it same, okay, over here, this one over here, B and A and B have the same magnitude. Okay, you can see that it's 45 degrees. The chair will be moving 45 degrees to the A or 45 degrees to the B. Any question? Can you imagine how this vector looks like? Everyone here, are you okay with the diagram? Understood? Okay. Okay, Ian, I got it. I think I should put Ian as the physics monitor. Okay, in the monitor, in the physics group, you are the monitor. It's easier. Okay.
Okay, sir. Thank you, sir.
So A and B, you can see, so everyone understood what is happening here. We have a two vector over here. When we do the sum, you can see that where is the chair is moving. So you imagine the chair is moving this way. Somebody is putting on top, going top, and somebody is putting on the right side. So if you understood, you put on the chat, understood. Okay. So I want to see your interaction with me. Okay. 1, 2, 3, 4. Only 4. 1, 2, 3, 4 replied. 5. Okay. 6. Okay. Now we're going to see um, how you get this sum. Okay. As I said, 1 is using parallelogram. So this estimation don't have the parallelogram thing. One more thing is using triangle. So you can see that if I take A, okay, A over here, I see I put it diagonally. So I put A over here and B in this way. Okay, so this is a sum, right? Okay, so A plus B, you can see this is A plus B is the sum of it. You can see that one thing that is that is important is the tail. Tail of A, okay, tail of A head to the B, tail of B head to the sum to the head of the sum. So if I adjust this one in this way, okay, you can see that it is still digit. It's here, it's still digit. Okay. Or if I put B at the bottom, A on top in this way, you can see that it has the same. If you arrange it A or B, you can see that it is same. Okay. So let's say I put one more vector, then C. So how does it looks like? So I put as A, as a B. It doesn't it does not have any rules which one to put first. You can put C here, you can put B here, you can put A here. By the end, you can see that it is same. But the arrangement head to tail, and head to tail. This is the important. Okay. So let's say C is pointing this way, right? It is opposites of A and B. You can see that it is same as before, right? So the sum of it is same as before. Okay. This is by using geometrical drawing. Okay. And later on, we're going to see that each of the each of the vector has its own values. You can see that A, or not here. Okay. Okay. So let's say V over here. V over here has a value in X. Okay. So in the X over here, where is it? In the X over here, It has a value. And in the y also, it has a value. So if you move, you can see that the value is also changing. And a vector also has an angle. So this is the angle between the horizontal. Horizontal is left to right. Okay, left to right. Nourish. Remember that, Narin. Remember that horizontal is left to right. Vertical is up to down. Okay.
Yes, sir. Okay.
So left to right, horizontal, up down is vertical. Okay. So if we change the horizontal vertical up down, you can see that by is changing and angle also change because it is counting from the horizontal. Okay. So if we also change, okay, if I change in the length of the horizontal this way, okay, this is changing in vertical, this is changing in horizontal. So if I change horizontal, you see that by does not change, bx change, and theta, the angle also change. Because if you change the any vertical or horizontal, the angle also will change unless you can increase both of them proportionally, then the angle can be same. Okay. So going back to the PowerPoint, okay, you already know, you can see that, okay, the sum of vector is when A plus B. Okay, when you put A at some one part, B at dot part, and then you can see that the head to the tail, then you can get the sum of the vector. Okay, so polygon vector, okay, is when you have a lot of vector. Okay, you can see the R1 plus R2 plus R3 plus R4. The whole thing R over here is sum of vector R1, R2, R3, and R4. Okay, you can see that if I put a lot of vector, where is it? Okay, clear this one first. 1, 2. Oh, you cannot put. Wait, you have to put a single color. 1, 2, 3, 4. So 1, 2, 3, and 4. Okay, so the sum will be in this way, head to the tail, same like the one in the example. Okay, subtraction of vector is a vector difference of R1 minus, let's say we have here R1 minus R2. So R1 minus R2, R over here is R1 minus R2. So where is the minus? So A minus B. A minus B equal to C. So A minus B. Okay, you can say the B is negative. B is negative means that it's flipped. So A minus B. So I put here this way. And C will be in this way. Okay. I want you to see. Oh, you put one more here, one more here. Okay. I want you to imagine that B now is negative. B negative, it means that it flip. Suppose, we can suppose if the head over here, right? So the head is flipped because B is negative. So head should be here. So A will be going to the tail of B, and the head of B is at this point. So you can see that it is actually same as the one we learned before. Right? It is same as the one we learned before. So the if you B, because you can see that the equation is B is negative, it is flipped. So if B is not flipped, the head of B will be at this point. The tail will be here. So as we learned before, if you want to uh add up sum the vector, it must be tail to head, head to tail, and head to tail. But from this one, you can see that the tail is going, the head is going to the tail. The head is going to the head. It is because the B is now flipped. But if you imagine the B here, the tail, the head is pointing here, and the tail is up there. You can see that it is the same as before. Okay, so remember, if you have a minus, it is a flip of that current letter. So B now is flip, right? B now is flip. So if B is not flip, means that AB is plus. So A, wait, how to, wait, cannot rotate. Okay, you cannot rotate this one. Okay, so if B, where is it? If B is plus, one thing. Okay, if the B is plus, how does it look like? Oh, okay. So this one goes here, this one goes here, this one goes here, this one goes down. Okay. Okay, you can see that it is same as before. Just like B is flipped because B is negative. Okay, see that. Okay. I hope you understood. This is just this is the best way I can explain to you by using simulation. Okay. I'm using whiteboard, I don't think you can see how does it work. Okay. Next we going to the you can see this is the PowerPoint again. Okay. Much more advanced is a vector product of vector. Vector also in physics we have a cross product. Okay, you can see here this is a cross product. Okay, and the dot product. Cross product is when we are using a 3D dimension. If you remember right hand framing rule, vector A and vector B, I'm using, you can see that my hand, vector A to vector B, as it's pointing upwards. Okay, so this is a cross product. C is the resultant of cross product between A and B. A and B will not be intersect at any point in the world. Okay, but the cross product is only intersect at this point, axis, origin point. Okay, so at this point, the cross product is pointing upwards. Okay, so it is like 3D. Okay, one of the example of this cross product is torque, T-O-R-K, torque. And if you want also find out the magnetic field, okay, the direction of magnetic field and the current is going another way. Magnetic field is going another way. You can also use this right hand framing rule. Okay, this is just application of cross product. Vector product. Okay, resolving a vector. Okay, if we have a x, you can see resolving. Resolving is one vector you want to, from one vector you want to separate into fx, fy. So let's say go back to the simulation. Okay, so clear this one. Okay, I put over here. So let's say A over here, we want to find out what is the x of it, how much the value of x horizontal component, how much the length over here, and how much the length over here. Okay, so this is called resolving the vector. Okay, so how to get resolve is by running out of time. Okay, how many time? 10 minutes, right? Yeah, 10 minutes for now. Okay, so how to get resolve is if fx is will be sine is a cos. Wait. If the angle over here, let's say the angle over here, it is a cos theta. Cos theta, if you use a triangle, if you use a trigonometry, is a cos theta. Okay, and fy will be the sine theta. Okay, you can see that fy over here is same. If you take this green and then you put over here, it will same as at the left. If you put this green, drag over here, it will same. So this is fx is cos theta. Okay, and Fy will be the sine theta. Okay, now this is the example that I want to show you. Okay, before I'm show, I think we can take 5 minutes break, and then I will post a new Zoom link. Understood? Can you understand? We have 5 minutes break, and then I put up a new Zoom link on the WhatsApp. Okay. Is it everyone okay?
Okay.
Okay, so 5 minutes break. I also want to take a drink, and then later I'll put the WhatsApp a link on WhatsApp. Okay. So
Okay,
5 minutes. Okay. Okay. So as I said, we're going to continue this one. As I said, the value of fx. Let's say this is the vector f. So we want to find how much the value of fx. So fx is f cos theta. Let's say the theta is over here. So fx cos theta. If you want to find how much is the value of fy, because actually fy over here you can put over here, right? So let's say I put the same green color. Okay, same length, same direction. Okay, so it is how to get the fy is f sine theta. Okay, how it is happen. This one you have to remind your at max or your max. Okay, horizontal f cos theta, vertical f sine theta. Okay, but if you have the value, if you have the value of f cos theta, you have the value of f cos theta, and you have the value of s sine theta, you also can get back what is the length or the magnitude of f over here by using Pythagoras theorem. So fx value, f cos theta, you put fx value, and f sine theta, if you have the value, it is a number actually. This is not the expression, is number. You put it under here, then you also can get back what is the value of the f. Okay, it is a simple maths. Tangent theta, you mean that you want to find how much the angle here, you get the value of f sine theta. Okay, you put that on the y, and f cos theta is a value of number, you put on the x. You divide it, and then you have tangent theta equals to y over x with a value. So tangent minus 1, then you get how much is the angle of it, okay, in degrees. Okay, it is a simple math. Okay, next we have example over here. Given an object is moving a constant, yes, Kugan,
sir, can repeat back again one more time.
which one?
The creation. This one.
Yes, which one?
The f square equals to fx square plus fy.
Okay, this is a theorem of Pythagoras. Okay, let's say I'm going to this. Okay, so fx equals to fy. If you have the value of this one, let's say this is 3, right? Fx is 3, fy is 4, right? So fx is 3, fy is 4. Then how much the value of f over here, right? So
Must
you
use
have,
the Pythagoras.
yes, using a Pythagoras theorem. So this is 3 squared plus 4 squared. So you have, by looking at it, you know that the f will be 5. So you can get the value of f by using theorem Pythagoras. This one plus this one. Okay.
Uh,
Okay. So that
sir,
is, yeah.
so the another one, sir, So the another one so was teaching the tangent and the cos, all the stuffs.
Okay, that one, if you want to find the value of fx and fy. Okay, eraser. I want to. Okay, let's say here. Let's say here you have angle. Okay, let's say here you have 30 degrees. Let's say here f is 10. This f, the black color, 10 Newton.
Okay.
Okay, let's say. So the question asks, how much is fx?
So
Okay.
I have the
So to find the fx, you can use, because it is horizontal. Okay. So this is green light. Okay, this is f. Then sorry, this is y. This is x. So to find the value of fx, okay, okay, we go to the deeper, we go to the basics of trigonometry. Sine 30, cos 30 degrees is equal to adjacent, that is fx divided by
x
f,
hypotenuse.
hypotenuse, that is 10, right?
Yeah.
Correct or not?
Yeah.
Can I find the value of fx here?
Yeah.
So fx
Cos
equals
8
to
times 10.
10 cos 30 degrees. Am I correct?
Yeah.
Okay. Now, so I can find this value fx. Can I find this value of fy? Sine
Yeah.
30 degrees equals to
Sine 30 equals to 10
10. Are you sure it's 10? Angle is over here, this one.
fy.
Fy divided by
10.
10. So can you find the fy? Fy equals
Yeah.
to 10
Times sine 30.
sine 30.
30.
Okay. See, you can get the fx and also you can find the fy. Okay.
Yeah, okay, sir. Yeah.
Okay. So if we want to remember, it's easy. If the angle is over here, the vertical up down is sine theta. Okay. F sine theta. If the angle over here also, and you want to find the horizontal left to right, it is cos theta. So F cos theta. Okay. Any question, everyone? Any question before I proceed?
Sir.
Yes. Somebody is saying something.
I said no, sir.
Oh, okay. You said no. Okay. So everyone is here, right? Okay. So this is how you get the, but it depends on the angle. If the angle is on this part, there will be the equation will be different. Okay. So we assume that it is angle to the horizontal, not angle to the vertical. That is different thing. Okay. Maths, you have to change it, cos and sine. Okay. Now, for example, over here, an object is moving constant acceleration, moving all the supply points is not proportional to the axis, but it's made. Okay. Find the angle of resultant force, angle theta in its force, n. Okay. So it says that I'll say same thing. Let's say this is a chair, one person pulling this way with 400 Newton in 80 degrees. One person is pulling in this way with 2000 Newton in this way 35 degrees to the horizontal. One person is pulling in this way with 1100 Newton in this way, going down, up here. So now we are, actually it's easy if you imagine that you are watching from the top, not from the side. It's easier you watching from the top. So 3 person are pulling the chair, right? Or anything up there with the rope. And we want to find where does the chair will end up, direction of chair and the force of it. Okay. So first of all, okay, we have to resolve all three forces F1, F2, and F3 into X and Y component. Okay. So see, let's say we have here, we do F1 first. F1, okay, this is F1, angle is 15 over here. Okay. What will be the F1, I'm talking the F1X direction. So this is F1X, this one. How to find the F1X? By using cos or sine, which one we are going to use?
Cos.
Yes, it
Cos.
is using cos. So to find F1X, it is 1100 cos 15 degrees, right? To find the value of F1Y, F1Y, what will be the equation? 1100 sine 15, right? Right not?
Yes.
Okay, so sine 15. F2, how to get the F2x in the x direction here, bottom here. So
Cos.
2000. Okay, wants to try. Okay, I give you a try. 2000
Cos 35, sir.
cos 35, correct. Okay, 35 degrees. F2y, F2y,
Sin 2000
2000
times sin
sine
35.
35.
Sin 35.
Okay, F3x, 400. 400
Divide cos.
divide.
Divide cos.
Divide. Are you sure you want to divide? This is 400. This is 80 degrees. So how to find this one? Fx. F3x equals to 400 cos
Cos
80
80.
degrees. F3y equals to 400 sine
Sine
Sin 80.
80 degrees. Yeah, there you have here. Okay. Now you're going to add up all the fx. So you can see if I put the table, it's easy how to get it. Okay, never mind. So clear. So it's easy if I put a table like this. You can see that this is f. This is x component. This is y component. This is f1. This is f2. This is f3. Okay. Okay. So fill in everything. F1x, F1x. This one, F1x is 1100 cos 15. For y, F1 110 sine 15. F2 is 2000. X is cos 35. Y is 2000 sine 35. F3 is 400. What is it? Cos 80. 400 sine 80 degrees. Okay. Okay, we cannot stop over here because actually the vectors has direction. Okay, if you add, you later on when you want to find f net, I mean y, the f net of x and f net of y, you have to do some operation because all these direction are different. Okay, so in physics we have understanding that pointing up is positive, pointing down is negative, pointing right is positive, pointing left is negative. Okay, so we have understanding pointing up positive, pointing down negative, pointing left negative, pointing right is positive. So let's see F1. F1, X is pointing to the right. Why not? F1, X is pointing to the right. So I put here is positive, positive there. Y is pointing down for F1. Y is pointing down. So I put negative here. Okay, can you see? F2, both of X and Y are positive. So this is positive. This is positive. For F3, Y is pointing up. That is positive. Y is pointing up, positive. And the Fx3 is pointing left. There. Okay, I'm any question until this point? Y is positive, Y is negative. Any question?
No, sir.
No. So everyone clear Y is positive, Y is negative. Because the direction of the understanding we know in physics, up, down, left, right. Okay. So one over here, you can see that we want to find what is the net, I mean the total of sum of everything over here for X and what is the number over here in Y. So if you want to find, this is what I have done. You can see that if I add everything, you can see this is negative, this is positive, this is positive, and we end up with 2631.36 Newton for X. Okay, X component of the net. Okay, the net of it. And this is the Y component of it. So minus, plus, plus, and you will do everything that is the number 1256.37 Newton. Okay. Okay or not? Any question? Any question? I just total up everything in the X and I total up everything in the Y. Any question? I assume everyone clear, right? Narine, any question?
No, sir.
Okay. So I have the number already, 2631.36 for X, 21256 for 37 for N. Then I can find the resultant. So resultant over here, I have this number for the Y, this number for the X. So I do the Pythagoras theorem, squared, and then root means square again. Then I have the value of it. So the value of the resultant force is 2915.90 Newton. This is value of the resultant force. How much the angle? Is easy. You put Y over X. So Y is 125637. 1256.37 divided by the X. X is 2631. 2631.36. So equals to tangent theta. Okay. So if you do the tangent thing, okay, tangent power of -1, you have the value of angle over here is 25.52 degrees. Okay, if you have a calculator right now, you can try. Okay, find the angle of that resultant force. If you have a calculator right now, you can try. 1256.37 divided by 26.31.36. The angle will be 25.52 degrees. Okay. Okay, now
Yes, sir.
where will be the arrow of resultant force pointing? Okay. So because you can see that the angle here is positive. Okay, angle here is positive, and one more, we also take account that the angle is measured from the horizontal. So this is a horizontal, right? This is horizontal. So we have the number over here. It is a positive number. So it is this way, 25.52 to the horizontal. Okay. Okay, so no question. So where is the resultant force? This is the answer. The resultant force is this red arrow. Okay. So when somebody is pulling this way 400 Newton and some people another people pulling in this way, and one more people pulling this way, the chair or anything that object will moving in this diagonal direction with 2915.9 Newton with the angle of 25.52 Newton angle degrees. Okay, so the chair will move this way. Okay. So I'm going to stop here. Okay, we done with the vector, we done with the scalar. Okay, tomorrow we have class or not? Okay, tomorrow we don't have any class, so I'm going to put one of two questions in the scalar and vector. Okay. Ian, put on chat who were absent for today class.
Yes, sir.
Because every class I have to report the attendance of the student. Nicholas and Sito. Sito is not here. Oh. 1, 2, 3. Xander Kwan also not here. Okay. What happened to them?
Sito has some family matters. The others I'm not sure.
Xander, not.
I don't know, sir.
Don't know. Okay. Missing in action. Okay. So going to stop here. Okay. See you in Thursday. Thursday. See you on Thursday. Okay.
Thank you, sir.
Before I end the class, any question on scalar vector?
No, sir. All good.
No. Okay. All
No
good.
question.
No, sir.
Okay.
Thank
Okay.
you,
See you
sir.
Thursday. Okay. See you.
Thank you,
Thank you.
sir.
Thank you, sir.
Welcome. Okay.